Hi, I'm Cody Qiushi, and this is my project 1 for Technology Design Foundation individual section. The title for my project is Variable Fonts equals Font. This project represents the first phase of a larger exploration. My goal was to understand how microcontrollers, sensors, and real-time data streams can communicate between a physical computing device and a website. I learned how to read and parse sensor data, send it through the Web Serial API, and use that live stream to animate typography in the browser. This proof of concept connects a ESP32 microcontroller and an MPU 6050 sensor directly to variable font parameters such as weight, width, and slant. Looking forward, I plan to extend this pipeline into a lyric visualizer that analyzes sound input, volume, tune, timbre, and emotion to drive expressive real-time typographic motion. Across the process, I developed 5 core skills: setting up and locally hosting a website and communicates with hardware through Web Serial, learning the basics of physical computing, sensor wiring, data parsing, and serial communication, mapping real-time sensor streams to font axes so motion translates visually through weight, width, and slant, and designing the hardware enclosure and surface layouts for LEDs and buttons to make the device usable and reliable. Troubleshooting and project management, prioritizing features, debugging both hardware and software, and planning for the future expansions. So coming from architecture and computational design, I initially imagined doing a Grasshopper project, but within the TDF context, I pivoted to treating data as a design medium, merging my interest in variable fonts with interactive physical computing. So the system components and fabrication. This system consists of a ESP32 controller, an MPU 6050 accelerometer, 3 buttons, and 3 LEDs. Each button activates a distinct animation mode, wave, sine, and jitter, while each LED confirms its state. On the website, data is read via the Web Serial API and translated into CSS font variation settings in real time. Physically, everything is mounted on a breadboard inside a simple acrylic box, creating an embodied interaction that you can literally tilt and hold. The final outcome closely matches my original proposal to use physical interaction as a driver for typography. The only pivot was introducing 3 distinct animation modes so the system became more performative and layered. The prototype successfully maps motion to typographic behavior and demonstrates a stable hardware to web pipeline. Latency is low. The buttons work reliably, and the system supports any fully variable font. The animation could still use aesthetic refinement, and the hardware shell could be more ergonomic, but technically it achieves its goal as a foundation for future iterations. Looking ahead, I see 3 possible directions for this project. First, as a lyric visualizer where sound analysis, pitch, timbre, and motion drives expressive typography. Second, as a motion adaptive display system for vehicles or wearables. Imagine text that stabilizes itself while you're reading on a bumpy road or moving train. Using accelerometer data to compensate for environmental motion could make interfaces far more comfortable and accessible. Third, as an open source designer toolkit that lets others map live sensor data to variable fonts without heavy libraries, bridging hardware and typography for designers and artists everywhere. These directions connect to broader research in responsive typography, embodied interaction, and motion interfaces. During the first critique, I received 3 meaningful pieces of feedback. Thanks, Thomas Chen suggested that the hardware shell could be more inviting. Right now, the acrylic box is neutral and functional, but there's potential to make it ergonomic and playful, so that the touching or rolling becomes part of the experience. Also, thanks to Bryce Parsons, raised a fascinating idea about creating a user-centered coordinate system. He imagined how typography could respond to the environmental vibrations on boats or vehicle, stabilizing text for readability. That opened my eyes to the potential for motion adaptive typography, a system that uses accelerometer and gyroscope data to minimize the perceptual mismatch that causes motion sickness in VR and AR. Nikhil suggested embedding the system into a gesture-based wearable like a glove. While I find that exciting, I realized continuous gestural input can be fatiguing. So my prototype balances both. Users can interact through motion if they wish, but they can also activate automatic looping animations and observe typographic behavior effortlessly. Together, these insights help me clarify my scope, not just a controller prototype, but a broader exploration of how typography can sense, adapt, and respond to its environment. To conclude, I learned 3 key lessons: how to bridge hardware and web interfaces through live data streams, how variable fonts can be used as a medium for embodied interactions and design expressions, how iterative prototyping from sensors to interfaces can build a foundation for a larger, more expressive system. Variable fonts in emotion marks only the beginning of a larger journey, connecting physical computing with digital typography to explore how data, motion, and emotion can shape the way we see and we feel text.